Now, we will discuss on topic 4.2 autocorrelation, when a variable exhibits correlation over time. We say it is autocorrelated or serially correlated. Recall that multiple linear regression assumptions consist of the independence of variable correct specification, no linear dependence in independence of variables, no autocorrelation in model residuals, residuals homoscedasticity, and normality of residuals. In this topic, we will focus on this part. That is to check no autocorrelation in the residuals of the regression model. Note that residuals actually is the estimated error. When performing multiple linear regression using the data in a sample of size n, we have error terms. Okay, we have error terms, where the error terms now is called residual. Note that residuals is the estimated error. Okay, residuals is the estimated errors. Okay, defined by EI equals to YI minus YI hat. One of the assumptions of linear regression model is that there is no autocorrelation between the residuals. For all I not equal j, that is covariance of EI and EJ equals to 0. The autocorrelation between two errors that are one period apart is defined as this formula. Okay. Consequently, the autocorrelation between two errors that are k periods apart is rho k, which is called the autocorrelation function or ACF. There are three tests to check on autocorrelation or serial correlation. The first test is the residual plot. That is the plot of residuals of the regression model versus time. This residual plot is useful for the detection of autocorrelation if the sign of the residual is randomly distributed. Okay, means that the correlation is close to 0, and we can conclude the model errors are uncorrelated. The residual plots can be used to examine graphically the IID. IID means independent and identical distribution assumption, as well as to spot possible outliers in the data. The second one is by using ACF plot. The example of ACF plot is as shown here, which consists of ACF versus lag. This is number of lag. If there is no serial correlation in the residual, the ACF at all lags will be close to 0. The third test on autocorrelation, that is the Ljung-Box Q test, or simply called as LBQ test on residual. The LBQ test on residual is used in the diagnostic checking to recognize whether there is autocorrelation in the residual of fitted time series model. Or we also can apply this test for regression model. The hypothesis for the test is as given here, where Failure to reach H0 means that the mean equation is correctly specified up to lag K max. The value of K max here, okay, can be no more than 20 or can be 15 or okay, suggest to use ln T, where T here is the number of data. Or Hinman and Athanasopoulos suggest K max here will be 10 for non-seasonal data and 2S for seasonal data, where S here is the period of seasonality. There is quite hard to get autocorrelation or to check autocorrelation using Microsoft Excel. Therefore, for this course, we will use R language. This is the R code for multiple linear regression model. This one, okay, and this is the R code for the autocorrelation for the multiple linear regression model. Let's look at example 4.2. In this example, we want to test whether the residuals of multiple linear regression model in example 4.1 is autocorrelated. There are three approaches can be used here. We go to the first approach, that is the residual plot. By using R code here, the plot for the residuals of multiple linear regression model for the data in example 4.1 is presented as shown here. It can be seen from the plot that the residuals value here are randomly distributed, which illustrates independence or randomness in the residuals of the MLR model. So that we can say the model errors here, okay, the model errors here are uncorrelated. The second approach is by using ACF plot. By using this R code on the residuals of the MLR model for data in example 4.1, and by taking K max here is equals to 15, the ACF plot is as shown here. It can be observed that all ACF values up to lag 15 are in between two standard error of ACF. Two standard error of ACF here is represented by these two lines. Okay, so we can see that all the ACF values here are in between these two lines. So it indicates that the ACF of the residuals of MLR model are relatively small and approximately equal to 0 up to lag 15, because the lag here that we take for this case, that is 15. Support the independency or no autocorrelation in the residuals. We also can get ACF plot at by default lag. Okay, by using this R code, instead no need to mention about the K max value here, so we can get the lag at by default. Okay. So R will give us the suggestion for K max for the residual data. As for this data, the suggestion K max is 12. Okay, so that the interpretation for this ACF plot, it will be the ACF of the residuals of MLR model are relatively small. You can see this is also relatively small because all the values of ACF also is in between these two standard errors. Okay, and approximately equal to 0 up to lag 12. Okay, because the number of lag here is 12. Support the independency or no autocorrelation in the residuals. The third test to check on autocorrelation in residuals is the LBQ test. For the LBQ test, it is suggested to use lag of Kmax either 15, okay, as suggested by Engel, or 10 as suggested by Hinman. If the data is non-seasonal, the result for LBQ test at lag 15, okay, is given here. For this test, we need to construct hypothesis testing as shown here. Since we want to use p-value approach, there are 4 steps that we need to apply. Step 1, okay, for the Ljung-Box test, H0 is no remaining serial correlation in the residuals versus H1, there is remaining serial correlation in the residuals. Step 2, get p-value. We can get p-value from the result obtained. Okay, the p-value is 0.6428. So now we go to step 3. Step 3, we will use the rule of p-value approach to make a decision on H0. Since the p-value here is greater than alpha, and alpha for this case is 0.05, since alpha is not given, so we use standard alpha. Standard alpha is 0.05. So for this case, the decision is do not reject H0. So do not reject H0 means that step 4 for the conclusion part, we can say at 5% significance level, the LBQ test indicates that there's no serial correlation or no autocorrelation in the residuals of multiple linear regression model up to lag 15. Lag 15 here because for this case, we use Kmax here is 15. If we use lag 10, okay, we need to change this as 10.